Right, so boys, we've got our ripple tank experiment. Very good at playing around with waves, okay? So just going to explain to you the setup. We've got, firstly, a mirror that goes around like this. What does this do? Yeah, look at the angle, 45 degrees. So whatever I'm doing here, rather than every student coming and looking from the top, what are you guys doing? It's the light, there's a light on the top that goes through it, because this is see-through, and it goes here, 45 degrees, yeah? Reflection, so you're able to see that on a translucent screen. So basically what I'm doing over the top, you're able to see it here. So that's just how it works. First thing, we're going to make a wave. How do we make a wave? So how do we make a wave? Disrupt. Disrupt wouldn't be the word I would like to use here. Displace the water. Like sound. Sound waves made by vibration. The first thing is just to make a little dip. What do we see? Can we see something on the screen, boys? Right, what do we call these? Ripples. Not enough. It's a ripple tank. That's just the name of it. These are called circular waves. What other waves do we know? Or circular wavefront. What other waves do we know? Sorry, what other waves do we know? We have got plane waves and we've got circular waves. What happens in diffraction? They go from plane to circular, right? This experiment will allow me to measure the water waves. How do I do that? So let's say I'm making waves. The waves are traveling here, aren't they? How am I going to measure the speed of these water waves? Good. So when you do a question about an investigation, always think about the equation first. V is equal to F lambda. To measure velocity of the wave in water waves, I'll need frequency and I'll need wavelength. Right. Hassan, how am I going to measure frequency and how am I going to measure wavelength? Think about it. How many waves, how many cycles, how many vibrations, how many oscillations, how many waves passes a point per second? How am I going to do that? Look at it. So the moment I start this, the wave is traveling. No cameras. So most of you will say, sir, pick a point on the screen. Oh, can you see how hard it is? How am I going to find out how the waves are passing it? So I need something to be continuously making what? Waves and ripples. Does that make sense? The vibration generator will just keep making oscillations. So on, please. It's vibrating quite fast. I can adjust the frequency if I want to. But can you see that the waves are continuously going down? What do I need now? I need a line. So let's say, for example, I put a line here. It's not perfectly straight. I start my timer and I count how many lines are passing that point per second. Does that make sense? Yeah? No. No one's listening. How many lines are passing the point per second? How are you going to count that? So what do? You do it maybe over a minute. In 1 minute, there was like 20 waves that passes the point, and then you want it over 1 second. You can work it out. Why did we do around a minute? Why for a minute? Wavelength is the distance between what? Two of the dark bands. One being bright, one being dark. Does anyone understand what is actually going on here? So I'll explain that to you. Imagine this is your ripple tank with the water being still, yeah? You push your finger here, all the vibration, the tip of that is pushing the water down. So this is going down. And as it propagates, so the oscillation is up and down, it's traveling that way, transverse wave, 90 degrees. On the surface, it does that. Yes or no? This is like more water. This is less water. High tide, low tide. Light from the top is coming. Which one's going to be a dark band? Height, because there's more water. So the distance from one dark to another dark is what? That's just your wavelength. And that's what I want to work out. So how am I going to work this out? Exactly. Guys, it's moving. How am I going to find the difference without using a phone? Some of you could say, sir, meet a ruler. I take a picture. I could then have counted the bands, couldn't I? Yeah? But I'm not going to use that. I'm not going to use phone. What do? What do? The stroboscope comes in. What's a stroboscope? Right? The stroboscope this is a manual one, and we've got one that's built into the machine. Have a look. Watch what's happening. Not much. But watch what's happening at the gain speed. Isn't it a certain speed that this is spinning? It appears to be stationary. Can I measure wavelength now? Yes, good. Right.